In this video we're going to be just looking at some integration. What is integration? What's the reverse of differentiation? So if I had a derivative, I had the derivative function of a curve, how could I find the curve, the original curve? So in this case I've got a times x to the n. Well, I know what differentiates the x to the n. Well, that's going to be x to the n plus 1 will differentiate. But obviously we need the a here. But when I differentiate this, I times by the n plus 1. The n plus 1 comes down. So I need to make sure to divide by this n plus 1. Whenever I differentiate these, this is called the reverse power rule, is I always find out what the new power is going to be. And then I just put in front 1 divided by that new power. Obviously you then need to put the constant as well, the original constant that was in front. Do you remember though, when we differentiate, there could be a constant here. Constant differentiates to 0, so there could still be a constant here. So we put a little plus c. The rest of them are fairly simple. So the sine x, well, what differentiates to sine x? That's cos, but this one's a little bit weird, simply because cos x differentiates to minus sign. So I need to put this minus here. The minuses will cancel. And I put plus c again, constants differentiate to 0. Alright, the next one, well, what differentiates to cos x? Well, that's sine. And this one isn't, it's just sine. And then I can put plus c. What about etx? This one's the easiest of them all. It's just etx. Plus c. And finally, the 1 over x. This one's very similar to up here. But the problem is, if I write this out as x to the 1, or the x to the minus 1, if I add 1 to this, I get x to the 0. X to 0 is just a constant, it's 1. But if you have a look at the graph 1 over x, I believe it looks something like this on both sides. Clearly it has a changing gradient, not a constant gradient. So that's just simply wrong. So what we do is we actually integrate it to ln x. Remember, ln x differentiates to 1 over x. And we put our plus c. We're finished. I hope this video was helpful. In the next video we're going to go through some harder integrals.